Everyone, so today we're going to be solving the week 4 chemistry AMS quiz. Now, it's all about electrolysis, which is coming with us in the periodic, but chapter 5 from the periodic isn't in this quiz. But this quiz is all about chapter 4. So let's start. An electric charge passes through a concentrated aqueous solution of potassium iodide, which is Ki. Which of the following are the two half reactions that take place? First of all, we need to know the series of reactivity, or the ones that have a higher tendency to get reduced or oxidized at the cathode and at the anode. So I'm gonna write them down both. At the cathode, we have the one that's least likely to get reduced is an A+. Then we have K+, then Mg2+, then H+, then Cu2+, and then Ag+. This is in increasing tendency to get reduced. I'm just gonna say reduced. R is reduced. Now at the anode, we have at the anode now it depends if your solution is concentrated or not. I'll tell you now how you know. It's SO4 2- is the least likely to get oxidized. Then you have NO3-, then you have OH-, then you have Cl2-, or it's Cl-, not Cl2-, Cl-, then you have Br-, and I-. Now look, first of all you need to know if it's molten or if it's aqueous. In this case here we have an aqueous solution. Now if our aqueous solution is concentrated, then we can have, for the anion, depending on what's the first thing, if it's more reactive or less reactive than hydrogen. And for the cation, for the anion, this is the anion. Actually, let me just show you on the graph. So first, you need to see K. K, where is it here? K is here. Since it's an aqueous solution, it means that you have Ki plus H2O, or H plus OH here, minus. So is K more or has a higher tendency than H? As you could see, K is lower on the arrow, so no, it does not. So H in this case will win. And since it's H+, it's gonna go to the cathode. So you're gonna find 2H+ plus 2 electrons turning into hydrogen at the cathode. Now for the I, since it's a concentrated solution, I has a possibility of going on to be your final solution or get displaced. So if it's I or OH, here we can tell that I has a higher tendency than OH. So then you're gonna find, since it's concentrated at the anode, you're gonna find 2I turning into I2 and 2 electrons. By the way, here's one thing. At the cathode, it's always gonna be reduction. At the cathode, you're always gonna have reduction. At the anode, you're always gonna have oxidation. So, and when you want to know if your equation is reduction or if it's oxidation, how I like to remember is if it's reduction, your electrons are gonna be in the reactants, reduction reactants. So if your electrons are in the reactants, then you have reduction. If they're in the products, then it's oxidation. So, and at the cathode, it's always reduction. At the anode, you always have oxidation. So yeah. Now let's move on to the next question, so it'll help you understand more what I mean when you have concentrated or dilute. Okay, here you have molten. So which of the following are the two half reactions of molten NaCl? When it's molten, you don't have to look at with water because the thing that's going on to your final displacement, like in your half reactions, is gonna be Na and Cl. You're not gonna look at any tendencies. So Na, since it's Na plus, is gonna go to the negative electrode, aka the cathode. So you're at the cathode, you're gonna find Na plus getting reduced, because reductions and the electrons are in the reactants. And at the anode, which is the positive electrode, you're gonna find Cl minus. Cl minus is gonna get oxidized at the anode. It's oxidized because here we don't really need to know, because here they're just asking us which are you gonna find at the cathode or the anode. But it's good to know that when you want to see if it's oxidized, if it's reduction, it's in the reactants. If it's oxidization, it's in the products. Anyways, moving on. Okay, so here you have inert electrodes are connected to the terminals of a battery, then immersed into molten Al2O3. When you see molten, then you know that your final products in the overall reaction, since here they want the overall reaction, your final products in the overall reaction have to be Al and O3, or well, O2. So you're gonna just split it. So you're gonna have Al and O2 in your products. So here you have H2 and OH. No, because you don't have it reacting with water since it's molten. Here you have H2 and O2. Again, no, because you're not reacting it with water. Here you have 4Al, O, and in your final product you have Al and O. Here you don't even have aluminium in the entire reaction, so this is just immediately wrong. Now, moving on. Which of the following is an advantage of a fuel cell? For these ones, you have to memorize the table in the chapter 4 notes. It's really important. It's not really any way to explain it, just memorize. It doesn't produce carbon dioxide. It produces a clean product, which is pure water. It doesn't have any harmful gases. So because it doesn't have any harmful gases, it reduces air pollution. So yeah. Here, it doesn't tell you it releases no gases. It means it's not telling you no as in no, it's telling you as in nitrogen oxide. It's not no, because it doesn't release any gases. It only produces pure water. But here they don't mean no as in no, they mean nitrogen oxide. So yeah, which is a harmful gas, by the way. And no, it's not used in flashlights. Moving on. What's the oxidation number of Cl and HClO? So for these, you need to memorize the table I keep giving you with all the oxidation numbers. I'm not going to rewrite it because it's going to take a lot of time. I wrote it in all my other videos though, if you want, for chemistry. So H is always positive 1. O is always negative 2. Cl, we don't know it. We want to find it, so it's X. So positive 1 plus X minus 2 equals the overall charge, which here is 0. So 1 plus X minus 2 equals 0. So X equals negative 1. So X equals, positive 1. Because 1 minus 2 is negative 1. When you move it to the other side, it becomes positive 1. Now, moving on to the next question. Which of the following definitions of oxidation and reduction? The process in which the oxidation number, because there's nothing called a reduction number. So whenever you see reduction number, just cross out your option. And from the name itself, if the reduction number decreases, it gets reduced, then it's reduction. If it increases, it's oxidation. The name reduction kind of gives you the answer. Here, oxidation number should not decrease, it should increase to be called oxidization. Here, they're asking us which of the following elements is being reduced in this equation. So to know which element here is being reduced, you need to look at all the elements in your equation. Here, it's O is gonna have it's gonna have an oxidation number of negative 2. Cr2 is gonna have a oxidation number of something we have to find. But let's find it really quickly. So 2x is 2. So it's gonna have an oxidation number of 3. Fe here has an oxidation number of 0 since it's an element. H also has an oxidation number of 0 since it's an element. Here, Cr has an oxidation number of 0. Fe also 0. Here, H has an oxidation number of positive 1, O negative 2. So as we can see, O did not change its oxidation number in both cases. Fe stayed 0, H didn't stay the same, but it increased, so it didn't get reduced. What's the only thing here that changed and got reduced? Cr went from being 3 to being 0. So Cr is the one that got reduced. And now you're gonna ask, why don't you put Cr3+? Because Cr3+ is your product. You need to give it CrO7 2-, because that's the one that split up and got reduced. It was the one that was more. So this is your correct answer. Moving on. So here again, it's about the fuel cell, which is the paragraph you have to read in the notes. Hydrogen fuel cell work like batteries, but they do not run down or need recharging. Choose the gases that are in a hydrogen fuel cell. As the name states, you obviously have hydrogen, and since your product is gonna be water, you also need oxygen. This is also, again, memorize it. It doesn't ever change. It's the same answer. Okay, so next question is asking us, what's the oxidation number of barium? So, barium and barium fluoride, you need to see. F, we always said it's -1. So since F is always -1, but here has a subscript of -2, it's going to be -2 here. And barium is X, and the overall charge of this compound is 0. So X minus 2 equals 0, so X equals +2. And that's your final answer. So barium's oxidation number is +2. Now, moving on. Okay, so here they're giving us molten calcium fluoride conducted using the below apparatus. So we're gonna have, since it's molten, in our final, like the things that get displaced at the electrodes, the things you're gonna find at the electrodes is Ca and F. Since Ca is Ca2+ and F is F-, 2+, since it's positive, it's gonna go to the cathode, aka the negative electrode, and since F- is negative, it's gonna go to the positive electrode, aka the anode. So at the negative electrode, which is the cathode, you're gonna find the positive one, so Ca. And you don't find the ion form, because in this solution, they were in ion form since they're molten. When they go to the electrodes, they become their actual forms, either gas or metals. And at the positive electrode, which is the anode, you're gonna find F2. Now here, for the next part, they're gonna ask us the half reactions. And I already told you that at the cathode, you're gonna undergo reduction. Because we said in our video when I was explaining the CQDs, to remember it, it's red, fat, cat. We said that when you use this, it's usually for electroplating to remember it, but you can use it also for general cases in electrolysis. Red means reduction, cat means cathode, and fat means because the thing that's getting reduced usually gets thicker, it gets bigger. So yeah. So since it's at the cathode you get reduction, you have to have reduction for calcium. And by the way, these equations, you don't have to memorize them. They're at the back of the periodic tables they give us in the exam hall. You just need to be careful that you're actually doing the one for reduction and not oxidation. So at the negative electrode, you're going to have calcium being reduced. So calcium, Ca2+, being reduced. And reduction always has the electrons in the reactants. So calcium being reduced to the ions being reduced to the metal. And they don't want state symbols here. And for the positive electrode, it's going to undergo oxidation. So you're going to have fluoride going into the ion going into fluoride and 2 electrons in the product since it's oxidation. These, again, like I said, you're going to find them in the exam. It's going to be on a table that looks something like this in the back of our exam paper. But here, like I said, be careful, because here in this table, these are all reduction half reactions. For us, we wanted fluorine as we wanted fluorine to be oxidized. So what if it's oxidation? You just flip these and it becomes 2F minus into becoming F2 plus 2 electrons. So here it was reduction. I don't know in the periodic tables in school what they have it as, but be careful. If it's reduction half reactions in the exam hall, you just have to flip the products and the reactants to make it oxidization if you want it. Anyways, back to the quiz. So, okay, so here we have different solutions and they want to ask us what are you going to find as the products at the cathode and at the anode. So here you have a concentrated solution of KBr. So again, you have to remember the arrows I showed you at the start of the video. So you have in this solution K plus and Br minus. If you remember the arrow, we said that, and since it's a solution, it's with water. So with H2O, which is H plus and OH minus. Between K and H, you're gonna always see H is gonna win between K and H. So H is gonna win and go on to form hydrogen at the negative terminal. Guys, remember, if it's a positive ion, it's gonna go to the negative terminal, which is the cathode. If it's a negative ion, it's gonna go to the positive terminal, which is the anode. And now between OH and Br, we said if it's a concentrated solution, Br is gonna win. You're gonna let the halogens win if it's a concentrated solution. If it's concentrated, Br is gonna win and go on to form Br2 in the product. Now, in the next example, we have an example about dilute solutions. Now, in dilute solutions, it's a little different. In dilute solutions, so you have Na and Cl. So Na plus and Cl minus plus H plus, which is water, and OH minus. Between Na and H, you don't really care here because either way, H is gonna win. Here. Since H wins, it's gonna go on to form H2. These are all, by the way, you can find them all in your in the arrows I gave you. And now between Cl minus and OH minus, if it is a dilute solution, it doesn't matter what this ion is, you cancel it and always OH is gonna win and go on to form oxygen gas. So again, here, CuSO4. And so you have Cu plus, is it Cu plus? I think it's Cu plus and SO4 minus. And you're gonna have, again, H plus, OH minus. Cu is stronger than H plus it has a higher tendency. So Cu is gonna go on to form the metal in the product between SO4 minus and OH. Either way, even if it were a concentrated solution, OH is gonna win. But let's imagine it's something that where usually OH will win, or well, usually it would win. Since it's a dilute solution, it doesn't matter what it doesn't matter what anion you have, OH is gonna win to go on and form oxygen gas. Now moving on. This question came a lot, so I'm gonna go over it quickly. To know if it's a redox reaction, you have to have change. If nothing in your equation is changing, whether it be the number of oxygens or the oxidation numbers, it's not redox. Here, since we can't really find the oxidation numbers, look at the numbers of oxygen. So in the reactants, you had 3 oxygens. In the products, you have 1 and 2. So 3 oxygens. So nothing changed, so it's not redox. Here, you could use both oxidation numbers and the oxygens. So oxygen here, 1 oxygen here. Nothing changed, not redox. Here, I'd prefer if you use for questions like this, redox. So here it's an element, so it had an oxidation number of 0. Here it's an element, so it had an oxidation number of 0. Here, since it's in a compound, O has an oxidation number of -2, and Cu has an oxidation number of +2, in this case. So here, they all got increased or decreased. So here there was reduction and oxidation, making it a redox reaction. Here Zn had an oxidation number of 0, H had an oxidation number of +1, Cl had an oxidation number of -1. So, and here H had an oxidation number of 0, but Zn had an oxidation number of +2, and Cl had an oxidation number of -1, because Cl is always -1. So Zn, as we can tell, the oxidation number for it changed. And so did H. But doesn't matter, even if it's only Zn, as long as you have anything's oxidation number changing, it is redox. Now, moving on to the next question. You need to find oxidation numbers. Whenever you see O, oxidation number -2 immediately. Since this one's set, now we need to find N. So you do the oxidation number of the thing you know times the subscript, so -4 it becomes, and then whatever you don't know, you label it X and make it all equal to the charge of the compound. Here it's equal to 0, so X minus 4 equals 0, making N be 4. And O, like we said, always -2. Here we need to find for HClO4. Like we said, O4, O always -2, H always +1. We need to find for Cl because that's the unknown. Cl is going to be labeled X +1 because you only have one H ion. You don't have to multiply by any subscripts. But O4 you need to multiply by the subscript. So -2 times 4 is -8 equals overall charge, which is 0. So it will be X minus 7 equals 0. So X equals 7. Since X equals 7, then the charge for Cl is 7. H always +1, O always -2. And now for the last one, MnO4 minus. So for Mn, we know O already, of course, -2. Now Mn, we're going to label it X minus 8, but this time you have an overall charge for the ion which is negative, which means -1. -1. So X will equal to, when you move this to the other side, it becomes +8. +8 minus 1 is 7. So Mn has an oxidation number of 7 and O has an oxidation number of -2. It's pretty easy to do these types of questions. Now moving on. Here it's a definition. This question, memorize it. It's simply a definition. The process of forcing an electric current into a system of chemicals as a result of which chemical reactions that normally do not proceed will proceed is electrolysis. What it's telling you that electrolysis is when you're just forcing a chemical reaction using electricity. Now here they're asking you which of the following represents electroplating. Whenever you want to represent electroplating, remember one thing. At one side you have to have a metal, and at the other side you have to have an object. It could be a spoon, it could be a nail, it could be anything that's not 2 sheets of metal. So yeah, now moving on. Okay, so here they're asking us for reactions at the anodes and at the cathodes. So always remember one thing. At the cathode, you will always have the object you're trying to plate. So you'll never have the sheet of metal at the cathode. It will always be at the anode. Why? Because of red, fat, cat. Since at the cathode it's getting fatter, it's getting thicker, you're plating it. The material will go to the cathode, and like see, Ag, the silver, is going to the cathode. So at the cathode, you're always going to have the object you need to plate. At the anode, you're always going to have the metal you're using to plate with. So the reaction is at the cathode, always red, fat, cat. So at the cathode, reduction, and reduction electrons are on the reactants. So you're going to have reduction at the cathode and oxidation at the anode. So Ag, and here this is for oxidation and this is for reduction. And that's it. Now, moving on to the next one. Here they're asking you, consider the following. NaCl2, P4, S8, C, and O2 are in their elementary state. So they're all elements. What's the oxidation number? All elements have an oxidation number of 0, no matter what they be. No matter how much is the subscript, no matter whatever they are, it's always 0 for elements. Here you have the oxidation number of fluorine in NaF and HF or in whatever this is. Always for fluorine it's gonna be -1 unless there's an exception. Actually no, there's not exception, sorry. For fluorine there's no exceptions. I mixed it up with something else. So yeah, it's always gonna be -1. And here they're asking us, given the following redox reaction, which is the element that loses electrons and how many? So here we had an element that had an oxidation number of 2, became 0, and Zn had 0 and became 2. But we don't really care because look, Cu had 2+. What does 2+ mean? How does an ion get plus? It's when they lose electrons, right? When they have lost electrons. So if this was 2+ and it went on to being 0, it went on to having a charge of 0, it means you gained electrons, because the only way to cancel out plus is with minus. So if it went from being 2+ to 0, then you had to have added 2-, which is 2 electrons to make it plus, or to make it 0. But here it went from being 0 to 2+. What does 2+ mean? It means that it lost electrons. So if it went from 0 to 2+, so if it went from being a smaller number to a bigger number, and then it lost electrons. But if it went from being a bigger number to a smaller number, it gained electrons. So the element that lost electrons is Zn. How many electrons is the 2? And I think that's it for this quiz. Study well for your periodics. Have a nice day. Bye.